A nuclear reactor is a system in which a controlled nuclear reaction, in this case nuclear fission, is used to generate electricity. The main components of the reactor are 1. Uranium fuel assemblies, 2. Control rods, and 3. A moderator. These components make up the reactor core, which is contained in the reactor vessel. Nuclear power plants use uranium as fuel. When neutrons bombard the uranium nuclei are split in a controlled chain reaction, releasing a large amount of energy in the form of heat. This fission energy heats up the water surrounding the reactor core. The steam generator takes the heat from this water and generates steam to run the turbines. The turbines will in turn spin the electrical generators, and electricity is produced. During a nuclear fission, a uranium-235 nucleus is more likely to absorb a low-energy neutron than the higher-energy neutrons produced during fission. Thus, high-energy neutrons are slowed down by the moderator, often water or graphite, so they are more likely to cause further fissions. The rate of reaction is controlled by inserting or withdrawing control rods made of elements, such as boron or cadmium, whose nuclei absorb the neutrons. Click the control rods and note any changes in the production of electricity. Click the different numbers in the graphic to know more about the parts and functions of the nuclear power plant. The containment structure is a concrete shield that prevents leakage of radiation from the reactor core. Uranium is used as fuel in nuclear power plants. Uranium is processed and formed into fuel pellets, which are about the size of a pencil eraser. The fuel pellets are then stacked inside hollow metal tubes to form fuel rods. Fuel rods are 11 to 25 feet in length. Before it is used in the reactor, the uranium fuel is not very radioactive. When the fuel rods are submerged in the reactor core, water can flow between them. The core acts as a moderator to slow down the fast neutrons produced during nuclear fission. Slower neutrons are more readily absorbed by the uranium. The control rods are made of boron or cadmium. These rods will absorb some of the neutrons produced so that the rate of fission is reduced. Steam generators are heat exchangers. When hot water is pumped through the heat exchanger, heat is transferred from the moderator, water, and generates steam to drive the turbines. Steam from the steam generator turns the turbine, which is connected to an electric generator. The electrical power output is delivered to consumers via high-voltage transmission lines. After exiting the turbine, the steam is condensed back into water that is returned to the steam generator. The coils in the generator will be turned by the turbine to produce electricity. The electricity is sent to users by cables. This pumps water into the steam generator, where it will be converted into steam to turn the turbine. Remove heat from the water discharged from the condenser so that the water can be discharged to the river or recirculated and reused.